the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello, everybody, and welcome to the Math Map Book Club. This week, it is January the 21st of 2026, and we are looking at Lesson 20, Closed Shapes. And so I'm not sure if Lee is going to pop in later, but we'll go ahead and get started with Lesson 20. So as we do every week, we can take a minute to talk about flashcards and some strategies. And this week, just a reminder that one of the ways that you can make flashcards perhaps less daunting for your students, if sitting down with a whole bunch of them feels daunting to them to go through, just have a few flashcards with different things that you do throughout the day. So, hey, as they're brushing their teeth, right, they can see a flashcard. When you sit down to have breakfast together, do a couple of flashcards. So you're not doing a whole bunch, but you're doing them throughout the day. And it becomes a part of, oh, we're transitioning. Let's do a couple of flashcards, right? Before you walk out the door, you have to look at a couple of flashcards. So that's just one way that you can take those flashcards and break them up and do something different. Does anybody have anything they'd like to share or ask about flashcards?
Somebody was telling me this week, they were looking at the iPages with their students, and they had their students go get their flashcards and find and match. And I thought that was a good idea because she said they love the flashcards and we're trying to figure out other things to do with them. But I really want to go through these iPages because like she feels like that's one thing that she doesn't really spend time on is going through the iPages at home. And so she said that really kind of gets them involved because they'll pick out items they know are in the flashcards and they'll go run and find them. So I thought that was kind of neat.
That's fun. All right. So this week, as I said, we're on lesson 20. So looking at our art, I think this is a really fun piece of art, especially for younger students. Some of the art may feel less concrete and maybe less accessible for those younger students. Or I oftentimes think about when I heard Andrew Pudawa speak in person once, and he talked about, and I'm sure he said it in his recordings, so I'm sure everybody's probably heard this, but he talked about the difference between boys and girls when it came to art. And he said girls draw a lot of adjectives and their pictures look pretty. And so they get lots of great feedback from teachers who say, wow, that's beautiful, right? You did such colorful flowers. You did all these great things. But his boys tend to try to draw verbs and adverbs, and those don't always come across as well on the page. And he felt that oftentimes boys didn't get that early encouragement to keep drawing. So he was just contrasting their drawings and why they were different. And so when I look at this piece of art, it's a piece of art that feels to me like there's some verbs going on, and we could maybe talk about some adverbs with it. So a great opportunity to maybe draw in some boys. Right. Last week we looked at the peonies. That may not have been as exciting for boys to talk about, but this week I think is a really great opportunity to talk about, well, what are the people doing, right? What would you do if you were in this picture? And so to talk about that action that's in this picture is a way to sort of pull some of those students in who maybe were not as excited about the peonies. So as I was preparing for today, these are some more kind of general questions when we think about our canons of rhetoric. They're less specific to this particular piece of art or this cover, but we could still apply them and encourage our students to talk about them. So if you're looking for sort of an almost midwinter or 2/3 of the way year through your year opportunity to talk about what are the canons and how do they help us, these are some questions that I thought of. We could ask them, how do the core skills help us build our memory? there's a way to go back and connect those core skills. So naming, attending, expressing, memorizing, and storytelling. I know I did them out of order, but taking those core skills and connecting them with that canon of memoria, right? Why are they so important? How do they help us, right? And then you could, once you've had that conversation, pull that into your cover, right? So if we want to remember this cover, which core skills would be really helpful, right? Would it be helpful to name something or to attend to something? What would help us to remember elements of this cover using those 5 core skills? For invention, we can connect those and remind our students that those connect to the common topics. So again, definition, comparison, circumstance, relationship, and testimony. So having them remember that those 4 topics go with this canon of invention. And we can say, well, what does it help us to invent? So sometimes we think of that as helping us to pull from our memoria. So it's related, right? Because it can help us to pull things out of our brain that are in our memoria. But when we're doing that with the intent of creating something, right? We're not doing that necessarily for the intent of passing a test. So this isn't a remembering for remembering's sake. That would be memoria. But invention is pulling things out of our memory in order to help us to create something, whether that's something that we're going to write, whether it's an argument that we want to make, or a piece of art, right? So if we were going to write a paper about solid shapes, right? We can use those common topics to help pull things out that we already know. And so that's sort of a nuance there between memoria and invention, and the purpose of those common topics being to help us to create something from what we already know. Arrangement, right? We can talk with our students. What are some ways to arrange what we know? How does arrangement help us? We talk about it a lot on our memoria and arrangement page where we think about tables. And so pulling that out, helping them to think, well, can we use tables? Could we make lists? Could you make a bubble diagram where you start listing things that you know? Right? An Annie chart, which we know goes along with invention, but that's a form of arrangement. And so taking those ideas of arrangement that we've learned in other strands and pulling them into mathematics and going, okay, well, what ways can we use those skills of arrangement here to arrange what we know? Elocution, it's just thought it would be fun to ask your kids, what makes math stylish? Now, when I think about elocution with respect to mathematics, I think we have to have the right units, right? Do my units match? So if I'm talking about the height of a building, does it make sense to say it's 3 inches? Probably not, right? So what units make sense? If I was talking about three of what might make sense for the height of a building? Well, it probably isn't miles. It could be stories. We might measure something in stories. It could be yards. Right? If it's a doghouse, it could be feet. But that's a way we can think about elocution with our students, right? That we're taking this idea of style, right? We're adding something to the number to give it more meaning, and to talk about that idea of elocution. And then when I think of delivery with mathematics, I'm always thinking of writing neatly and showing my work. When we think of delivery, we're always thinking about how do I take what I've done and communicate that to somebody else, right? How do I deliver that to somebody else? Sometimes we do it orally, sometimes we do it in writing. With math, oftentimes it's more common to see it done in writing. But you could also, especially with older students who are gaining some confidence in the order of operations, right? If I said 4 plus 3 times 2, do I mean 4 plus 3 is 7 times 2 is 14? Or did I mean 4 plus 3 times 2? So 4 plus 6 is 10, right? What did I mean when I said that out loud? And how could I how could I be more clear if I'm saying something like that out loud? I want to make sure that I'm clearly communicating to somebody, right? What did I mean? So there's where we can bring these canons of rhetoric into our math classroom and help our students to appreciate that they apply here too, and to discuss how they apply and how we know that they matter and are important. Does anybody have anything they'd like to share about this cover or about the canons?
I would, I love that we always go back to the 15 skills. And I think sometimes we, or I, maybe other people too, look at something and think it's hard. But if you just look at the 15 skills, you can have a really great conversation. And so I love that you include that for us each week to remind us. We can forget in 1 week. We can forget. So we really do need that weekly reminder. I appreciate that.
You know, sometimes it feels like, oh, well, people know this, right? We're doing the same thing every week. But I know as a former CC parent, my kids have now graduated, so sad. But I know that it took me a long time. Really working on the math map is what's helped me to hone my understanding of these 15 skills because I've looked at them over and over and over again. And so I don't want to assume that anybody already knows this because I think that there is great value in coming back and remembering what are we doing as homeschool parents. Our primary goal after seeking the Lord, right? Educationally, my primary goal is to make sure that my children know how to learn because I won't always be with them, right? Whether you send your child off to college, whether you send a child off to the military, whether they go to fire academy, right? Wherever they're going, whatever they're going to do, there's a really high likelihood that they're going to have to learn something new. And you're not always going to be there to help them. And it's been really encouraging for me as a parent to see my children in these environments choosing to use their classical skills and even acknowledging that they're using their classical skills in order to learn. And that gives me confidence that they don't need me as their teacher anymore because I did my job, right? And I've given them those skills. So now they don't necessarily rest on the content, what I taught them. Right? You laugh about that because we all know we can all sing at least half of the timeline song, right? So together we get through the whole thing. We don't use that every day, right? But we do use the skill of memorizing, right? We use the skill of attending. So I really want to encourage our families, especially when we look at mathematics, because we've been really indoctrinated to think that the content is king. And I don't want to say the content doesn't matter because we know it does, right? We want our kids to learn something, but it's the ability to learn that is really our goal. And when you graduate your kids and they show that they can learn, that's really when you feel like you did your job, right? We don't go back. I don't go back and give them math tests anymore. But it is encouraging to hear them using their skills without me prompting them. Now, I wanted to make a note because we did get this question in about this checklist here of what we're going through. So, right, we keep saying that this is the math map at home, and we're going through this flow, uh, day 1, day 2, day 3, day 4. And if you didn't know, every single book of the foundations level domains has this checklist in it. So if you tend to skip over those I pages and go straight to the lesson pages, you're missing the checklist. And so that's why we have two separate math maps here, is because the one on the left is in all of those foundations level domains: digits, naturals, integers, decimals, fractions, rationals, and reals. Once you hit the challenge domains, where we have our complex monomials, binomials, polynomials, expressions, and transcendentals, Those domains have a blank page here so that students have a place that they can take relevant notes. Right? There's still room for notes in the foundations level, but that's where we added that checklist. So if you're looking for that checklist, if you're going, I love the Math Map Book Club, but I never remember the order, it's right there in your booklet for you to use. Now, if you're a challenge parent and you're looking for that, that is not in your booklet, but you can go to the Math Map uh, companion in CC Connected, and you can actually go and take a look at those foundations level domains. And so you can actually go and see what that looks like for those domains if you're looking for a place to grab that. But it also, just to clarify, this is the same flow that we've given you in your challenge guides. So that's why it's here for foundations level. You get that same outline in your challenge guides for your students. Any questions on that? Okay. So looking at our strategies for our lesson pages, we're going through and we're revisiting some things that we've talked about. And this week we're going to talk about reading the pages aloud. And so even though we're here on lesson 20, right, there's no expectation that, oh, you already know everything and you don't need to read anymore, right? It's actually a really great time to remind your students, hey, before you do anything, or if you're really overwhelmed, let's just stop and read. We're entering in here with our 3D and our 4D lessons. The lessons are very accessible, but the content is probably going to be unfamiliar to you as parents. And unless you have a very unusual math education in your home, I can almost guarantee that it's going to be unfamiliar to your students in their first year. So we're about to see a lot of unfamiliar content. And it's a great reminder to stop and not be overwhelmed by the unfamiliar content, but just to stop and read. As we're reading, you can look up unfamiliar symbols. Or as Bab was talking about earlier, right? That's a great time to go and grab those flashcards that match. We can look up unfamiliar words, right? So if we come to something and we go, I don't really know what that is, this is how we can help our students, how we can model for our students, going and looking to see if that word is in the charts, or if we need to go and look it up in the glossary, or if we can decode that word from the context. If it's a totally unfamiliar section, you can say, hey, we're not going to worry about this one. We'll come back to this one later, right? So there's a lot of different strategies we can take when we're reading that page aloud and we're looking at the unfamiliar content. It's also a really great reminder to talk with your students and discuss what the instructions actually say and what that means and what it doesn't mean. Okay? So if the instruction says trace, then all we need to worry about is tracing. You don't need to be able to draw these on your own. You don't need to be able to analyze it, calculate its volume, right? We don't need to do any of that. All we need to do is trace. And so reminding our students, especially when we're looking at things that are unfamiliar or might feel overwhelming, to stop, read that instruction. And then if you're doing this, right, a great thing to do is not just to do it once, but to come back the next day. Hey, let's read that again. Do you remember what these symbols and words mean? And it's okay if one whole day of your week is reading, or two, or three, or four, right? If you just read through it in your first year and become familiar with the words and the symbols. So it really is up to you how much you want to do that. But I want to just remind us all how valuable it is to stop and read. Anybody have anything they'd like to talk about when it comes to the lesson pages?
Well, this actually happened this week. So a tutor came to help to our help desk. It was either week 18 or 19, and it was where we were plotting points, but then there were these unfamiliar equations and we were plugging in numbers. So we were just talking through them, and it looks overwhelming at the first glance. But I was like, but all we have to do is plot the point. We don't have to do anything else except plot the point. And I think one of the instructions said study. And so both of us just started laughing and we're like, we're getting all excited about what we see here. And basically the directions just said study. I mean, we had to plot a point and then we had to study. And so I agree that sometimes we just need to slow down, and especially if it's a page that looks overwhelming, if it's busy, to just read the instructions because most of the time they're not asking you to calculate. They're asking you to do something pretty simple. We just have to slow down and read what is actually asking you to do.
We don't really like slowing down, do we?
Mm-mm.
So here are our lesson pages. For page one, does anybody have anything on there that they would like to talk about? I think this is a great example here of how these domains are changing, right? And how if we're sitting together at the table, we could really have one common conversation because just reading tetrahedron and hexahedron and octahedron and dodecahedron and icosahedron, just being able to read those out loud, right? Everybody can count the edges, everybody could count the faces. And so there's grammar here that we're practicing, right, from year to year. Looking at the integers and the fractions, we can see how the one might help us with the other, where we've got some of our, uh, I can speak, right, where we see that we've got some of our diagrams right there. We've got dots, and the integers might help us figure out which way we should connect those dots. This is also a lesson where if you have manipulatives, if you happen to have a set of those shapes, right, a lot of us, I was talking to somebody yesterday who's thinking about joining CC. I think that they're going to join CC. They had a 2-year-old and a 4-year-old. So really at the beginning of their homeschooling journey. But we were both saying, yes, as homeschooling parents, what do? We want to just go buy everything and more for ourselves from our students than for our students. And that's one thing that I had and hung on to for years were just those solid shapes because it's something that we can actually count, right? We can hold it in our hands and count versus trying to do the 2D models here. So that if you have those is helpful. If you don't, taking a look around your house and going, okay, well, what do we have here, right? Do we have some cylinders? Do we have some cubes that we have here? Right? What other shapes might we have here that we can go and grab?
Some of I think it's the tetrahedron, maybe. I feel like when we were in Essentials, we bought these crazy dice, and a lot of those had those weird kind of shapes. So they're not giant, but they're big enough where you can see the faces and the vertices and the edges. So I know we still have those from Essentials. I think we were using them to play in 2K to have different kinds of numbers than just the regular dice.
It's fun. All right. So on day 2, this is our invention page. This is where, again, we look and we're practicing those 5 common topics of invention, right, to help our students invent something new. And in this case, one of the things that we're inventing is this idea of telling us everything that they know, right? So it's a little bit of pulling from Memoria, but it's also this, okay, create this. What you're creating is a demonstration of what you know by using these 5 common topics. So this week we're talking about circumstance, which I learned as same time, different place. And so I still remember that very simplistic definition and the image of a bullseye. And I thought that what might be fun is if you were to take, you could even take a piece of patty paper that's somewhat translucent and use a highlighter on it to make your target shape, and then just place it over the top of your I squared page, right? So I've just randomly put my piece on top of my I squared page here. And I could say, okay, well, what's in the center? What is that that's in the center?
Is it a 4D sphere?
Well, I was just noticing that those dimensions there don't actually match up. So that might be something that we need to send to Lee because I'm pretty sure that should say 3D. Um, or I think the idea is that it's yeah, if that shape was in 4D, it would be unbounded, I think is the idea there. So it is a 3D shape, but if we were to look at it in 4D, that extra dimension would create it being an unbounded shape. So that's I think the difference that Lee is trying to show there is actually that it's not a 4D shape. It's a 3D shape and it's bounded and closed in 3D, but in 4D, if we were to add another dimension, it would be unbounded, which we can't really picture, right? Um, so there's a great opportunity to talk through with your students. What do you think is meant here, right? We've got to look at the arrangement of this as well as what is um, there.
Do you mind talking for just a second about what unbounded and bounded would mean? Because I'm having trouble
Sure.
thinking about that.
Um, so a line, let's think about let's just use a one-dimensional idea here. A line is unbounded in any dimension, right? So here's my line, and it's unbounded because it just keeps going. If I was to look at a segment of that line, so I'm looking at just the part that's now between those 2 points, that's bounded, right? There's a boundary to it.
Right.
And
Okay.
even if I was looking at this on an axis and I had an open circle, it's still bounded at that open circle. Even though that point isn't included, it's still bounded. It still doesn't go past it. Okay. Now, when we think about if I was to think about this segment, right, it's a one-dimensional segment and it's bounded. But now, if I was to put this into 2D, and I was not defining it as a segment in 2D, and this is where it gets sort of, I think, I wish you could see inside my brain. But in 2D, if I'm saying, okay, I've got this segment here, if I added another variable, right, and I said it has to be true, right? Let's think that this is X. And so I'm saying that X is between A and B. Well, if I went into 2 dimensions, I'm saying this is true about X, but it's true for all of the Y values,
Okay.
right? So now notice we don't really have a way of drawing, right, infinite planes. But think about this, if it goes this way, right, it's not bounded anymore because there's no boundary on the sides. It can keep on going.
Okay. Yeah, this is starting to make sense.
So that's the idea. And can I have a bounded segment in 2D? Yes, I can. But if all I've defined is that X part, and
Right.
now I say, okay, well, it's got to be true for all Y, then it's got to be true for all Z. You know, I could
Mm.
in 2D, right? I could think about I have this circle and I said it's true for X squared plus Y squared equals R squared. I've given it some definition, but now I've defined it there. And now I say, okay, well, now imagine that that's in 3D. Well, it has to be true for every Y. And so it's bounded in 2 dimensions, but in 3 dimensions, it's going infinitely up and infinitely down, just the way
Yeah.
that I drew it, right? But it's this sort of infinite cylinder because it has to be true for all of our Z.
All of the Z's. Okay.
And so
Yes.
now what was closed in 2D, once I spread it out and it's infinite, It's unbounded in 3D. Does that help?
Yes, very much. Thank you. Thank you. I could get it with just 1D, but I was having trouble as we went up the dimensions. So yeah, that's very helpful. Thank you.
So now if we, and that's where the pattern finding helps us, right? Because now I take that
Hmm.
sphere and I say, okay, it was true for X, Y, and Z. So it's bounded in my 3D space. But if I look at it from 4D, it has to be true for every value of that third variable, right? And or that fourth variable. And we don't know what that looks like, right? We don't know what but it has to look, it has to be unbounded in that 4D space. And so that's what this is, this particular arrangement here is trying to help show that pattern of something that is um, unbounded, right? And bounded, and how the bounded thing becomes unbounded when we add another dimension to look at it in. So as we look at this from a circumstance, right, point of view, that's a great conversation to have, right? Because now we've just talked about how the circumstance of our dimension has really changed how we are looking at this particular shape. So with your older student, I think that's a really great conversation to have. With your younger students, I would come back to not worrying so much about the arrangement, but just say, okay, well, what is in the center? It looks like a sphere. Well, if we went out one, right, to this white, now I have a 3D shape that's not round, and I have a 2D shape that is round. And that's a fun thing to talk about, right? How they sort of together make this thing that's in the center. Um, and then what if we go out one more? What if we go out one more? What do you see? Not even necessarily looking for a relationship between them or how they impact one another, but especially with our younger students, just saying, okay, we're going to start here and we're going to look at gradually bigger circles around it. And that doing that on a physical page is going to give them an opportunity to think about circumstance so that as they progress, and now we might think about circumstance in a more global sense, we can do that with our imagination because we can't do it physically. It would be the same. Another way you could do practice circumstance concretely like this would be to get a map, right? Um, I don't know why when I think of circumstance, I always think of Nat Bowditch, and right, he was in New England, but then what other things impacted him? And we see, right, he was over in Europe and in the wars and these different places that he sailed to. And so that gave us this sense of circumstance, right? Here he is right now, but we know that there's other events that are going on in the world that are affecting his life. So you could do this same idea with a map, right? To help your students think about these ever getting bigger circles until they're ready to do that just by thinking through it. Any other questions about this page or about circumstance? Right. So on day 2, again, we see that there's a lot of commonality between these lessons, really giving us that opportunity to have that family conversation, adding more details each time. And here's a great opportunity to really connect this with your geography, right? Because we're going to be talking about the globe and how we find places on the globe, which is a little bit different to spherical coordinates because we usually just use 2, right? We might use our latitude and our longitude. We usually just use 2 coordinates because we assume that there's a constant radius. So if your students want to talk about why do we only use 2 coordinates, right? In our globe studies, it's because we're assuming that that radius is fairly constant, right? Unless we're flying a plane going in a submarine, climbing a mountain, then we start to talk about the altitude off of that surface. Any questions from page 2?
What is the difference between the capital R and the lowercase r on monomials in the bottom portion?
Sure. So with this torus shape, when we're calculating the surface area and the volume, we're looking at 2 different radii. And so the big R, let me make sure I've got my pen turned on here. So a torus is kind of like a donut, right? And so my big R is going to be from the center. Oops. How I turned the pen off. It's going to be from the center to the middle of the torus part of the donut. And so that is the part that's my big R. And then my little r is the radius of the donut part. So if you think about it, right, if you have you can have a donut that has the same big R, right? That the kind of giving us that idea, like, right, it's got the same rough size, right, donut, but they can have different centers. So you can get those donuts that are kind of like skinny, and so they have a big center. So that would have the same R and a little r. And then there's some that have, right, there's like almost no center. So it would again have the same big R, but a bigger big R. So that is how we can kind of judge that torus and how fat it is, and do those calculations. Does that help?
Yes, thank you.
You're welcome. The day 3 is our I cubed page, looking at memoria and arrangement. And so again, we're practicing those 5 core habits of memoria. And this week we're talking about naming. In the master's class this week, we talked about nominative definitions. And so I thought that this was a great place to talk about that. A nominative definition was giving a name to something, differently to defining a circle, where I can say x squared plus y squared equals r squared. Right, that's a constructive definition. It's telling me how to build something, but a nominative definition is giving a name to something. So when you think about naming, it's related to definition, but it's really that we're starting with the object and adding a name, right? Versus a definition would be, I've got a name and I'm going to tell you what the object is, or I'm going to tell you some essence of that object. So the 2 things go together here, but when we're naming, we're really looking at using correct words and terms. So as you look at this page, there's a lot on this page. Some things that we can do to scaffold looking at a page like this with naming is just to start by reading the names of the figures. Right? And that's obviously something you might probably have to do with a parent or an older sibling, right? But just to read the names. Another option would be to write the names. So to make copy work by writing the names down. The next step might be to make a puzzle. So you could take this page, especially after you've done some work on the other page, and you could cut it apart, right? And make a puzzle for your students to have to put back together so that they match the names of the figures to the figures themselves, right? So I could go ahead and I could start. And you can either make it so they just have to put the 2 pieces together, right? But I could cut apart my figure from its name. And then they have to match those together so that they don't have to read, they don't have to write, but they have to be, or read aloud anyway, but they're going to match and practice those names that way. And then finally is just to go through and cover up those names and then ask the students to name the figures. Those are some ways that we can use naming and scaffold it depending on the familiarity and the age of our student, to practice naming and build our memory work.
I was going to say you can also make flashcards. Think that
Always a good choice.
Mm-hmm.
Yep. Making your own flashcards is always an excellent choice for things like this. Yeah. Any other questions or things to share from this page? Here is page 3. This is a great page to look at, especially, I don't know when the memory work falls, but I think it's pretty close that this is around the right time of the year for the foundation's memory work to line up and be able to practice some of that foundation's memory work and see how it connects in with the work that the students are doing in the math map. And this is also a great opportunity to actually go to your drawer and get your measuring spoons out or your measuring cups out and actually practice, right? And have them take 3 teaspoons and see if they can pour 3 teaspoons into a tablespoon, right? Can I take some tablespoons, right, and make an ounce? And could I take those ounces then and make a cup? And then you could even have them, right, without actually having to do the math calculation, right? If it takes, if each ounce is 2 tablespoons, right, you could actually have them figure out how many tablespoons go in a cup just by measuring. And then you could do the calculation to see if it matches. So there's a great opportunity, again, to get some hands-on, right? We're in 3D, so giving your students some 3D opportunities to work with this. Similarly, with the nets down at the bottom where we're unfolding, right, is take a tissue box or an Amazon box, right, and actually unfold it, right, so that they can see how the box or the shape that whatever shape you're using, how does this unfold, right, and to practice what some of those nets are, taking those 3D objects and turning them into a 2D net. It would be fun. It would be fun to, I was just thinking as I said that, right? It'd be fun to take an oatmeal container, right? Because then you could actually see how you end up with 2 circles and a rectangle. That might be hard for your students to visualize. So taking an oatmeal container, right? Make some cookies and then take the container and create a net to help your students be convinced that that net really does match the cylinder.
I have to kind of laugh, like, because when you get to the 3Ds and even starting from booklet 16, we realized that when we sit down at the table all together, my oldest kids who are in complex and reals, they keep looking to their siblings, young like fractions domain, and say, these pages are much more fun. They look more, they have more pictures. This is not fair. And so, and I'm glad that they're looking at it, but it's a hard issue that we have to address. But for the complex students and students who are coming in the middle doing reals and complex, and all of a sudden there's a jump that their pictures, there's no longer pictures and colors in their books anymore. And it's kind of hard. They have to unlearn so much what they have done in other curriculum, and then they have to learn, and not only learn but compare and be jealous of their siblings. And so I'm here mostly today for encouragement because I'm hitting a wall right now on booklet 17.
It's that it
Well,
is hard. Yeah, it's that jump. Go ahead, Lee. Sorry.
well, it's not just that, it's it's the beginning of the new year, and 16 and 17, 16, 17, and 18 are kind of a difficult trinity of the 3 booklets. They all have higher analytical math in them than you're probably used to. So, but the breaks are coming. 20s, look, 20's easy. Tell them just get through it. 20's coming.
Thank you. Thank you.
Well, the other thing you could do, Yating, is say, okay, well, look, if you want pictures, draw the pictures. Show me that you understand this by creating your own illustrations, right?
Oh,
Take
wow.
your colored, take your colored pencils, take your markers, whatever it is that you want to use, and you illustrate, right? So we could look at, right? So for example, here, right? You could say, okay, well, what would 15 ounces look like? Right? Think about that. Well, over here, it's these sort of little cups. Does that work for you, or would you rather use something else that represents ounces, right? And so draw a cup, right? Maybe you draw a mug because you know that your mug holds 1 cup. And so I have 1 cup, and then I have 8 of whatever I chose for ounces, right? Well, maybe my picture looks more like, yeah, this is really not me as not an artist, right? And so I have a pitcher and I have 2 cups. So tell them, well, look, if you think you know what you're doing, you illustrate it. And that's a whole learning skill on its own, right? Is to be able to create an image based off of what you're looking at here. And so that way they get to make their books look just as nice as their siblings do. And they probably don't even know that you're being sneaky and making them think through and explain what they know just in a different medium.
That's cool. That's a really good idea. Thank you.
All right. So looking on day 4, we get to the careful calculations. And it's interesting that this already popped up today talking about slowing down, because I thought that this week, if we talk about emphasizing the careful part of careful calculations, right, you could think about using a reverse timer to make your students slow down. So instead of making them work fast by having a timer, say, okay, we're going to set a 1 minute timer and you're going to spend 1 minute on each problem, right? For however, right? Pick your, so maybe you only get 10 of them done because you say you're going to do this for 10 minutes. And then make them think, okay, I have to show every single step, or I can work on separate paper. I can show the checks working backwards or practicing with a calculator, right? So think about my shape. Well, how it might seem really easy just to count the faces. Well, could you draw the net? Especially for an older student, can you draw a net that shows me all 4 faces, right? Can you use different colors to show me all of the vertices and all of the edges? So making them slow down, right? I really want to see this be careful. I really want to see you be detailed, to show me the work, to show me the steps, to show me that you checked your work, right? You got through it, great. We'll go do it again. You still have, 15 seconds left. Do it again. And now do it quickly or do it a different way, right? And so making them slow down and not rush through is one more way that we can help to change the way that they're looking at this page and really emphasize what it means to be careful and to think deeply, not just rush through. So, anybody have anything they'd like to say about the careful calculations page?
If you wanted to do, like, have them look at this and then do something a little more freeform, you could almost play kind of like a double ditto, where have you ever played double ditto? Where you're looking for things that you have in common, but also something you found that no one else found. You can kind of score it however you want, but you could say, all right, everybody study this, look at it. You could look at any place else in the booklet, but then put that aside and say, all right, now everybody has a blank piece of paper. You have 1 minute or however long, and I want you to write down or draw everything you can think about with a 3D triangle or pyramid. All the different things. They might do the truncated, they might do formulas, they might do faces and vertices and all those things. And then you're saying, okay, what's something you wrote? Did anybody else also write that same thing? Did you draw a net? What did you do to kind of let them kind of almost blue book it, kind of, get out what they put in over the week. Just for something a little more conversational, especially if you have more than one student who is at a close enough level that they might have studied those things together.
I think it's a great idea and something you could easily do with multiple students, and another way to get them to think deeply and pull out all the things you know about one thing. So I think it's a great idea. All right, looking at page 4, again, we see a lot of commonality. So this is a great time when you see so much commonality, right? There's always commonality between our lesson pages in terms of there being similar concepts and similar ideas. But there are some weeks where it's even more similar than others. And so when you see this, it's a great time to say, hey, we are really going to sit down and work together this week. Right. And look, there's some pictures here, Yating. So your kids can enjoy, right? So let's look at this idea of the nets, right? We've got some of these are the same, some of these are a little bit different, but how can looking at one another's help us? Could we create a net from an object, or could I give you a net and you figure out how to fold it up together? So there's another fun thing to do. There's a lot of paper crafts out there that you print out and you get a net, right? And then you cut it out and you put it together. So there's a fun thing you could do with your students is to give them each a different net and some tape and some scissors and say, see if you can figure out what this is, right? Follow the instructions to fold this up. And that would be, again, that freedom that we get with the math map. Unlike other traditional curricula, but one of the freedoms that we have is to say, we don't have to do everything that's on this page today, right? We can come back and we can pay more attention to that next year. This year, right? We've been locked up in the house. There's an ice storm and we're locked up in the house and everybody's a little stir crazy. So let's just play with nets. Let's just take, right, the Amazon boxes and break them apart and make them flat and then put them back together again, right? Let's see what are the things that we can go in the house and find that we can like tear apart to create a net, right? Oh, we have that deflated soccer ball that's out in the garage, right? Well, let's go and see if we cut it apart, what does it look like when we lay it flat? Does it look like this net here on this page? Um, so I really, every week, I know I keep saying this, that you have the freedom to dive deep where you want to dive deep. And you have the freedom to meet the needs of your students that week. Sometimes that means I'm going to impose discipline on you and I'm going to make you do the page that's in front of you because we need to be able to have that discipline. But it's okay that we're not like that every week, that we give our students some freedom to explore. So maybe every week each student gets one thing they get to pick, right? Maybe day 4 is your day to explore, and every student gets to pick one thing that you're going to explore a little bit more deeply. And so you say, instead of doing the lesson pages on day 4, we're going to dive deep into this. So maybe somebody was really interested in these axes of symmetry. And so you say, okay, well, let's go get a tissue box and some skewers and let's see if we can make these axes of symmetry, right? That all of that is still learning and it's all really good learning. So I really want people to feel free to do that and know and be confident as we're showing here, right? If you do that in one year, you're going to see the same idea the following year. So you're not going to miss out on things.
I was going to say, would like crochet or quilting be similar to the idea? Like, because you need to count the number of stitches before you make a loop or something like that. And then turns out to be a net, and then all the stitches have to match up. Right. That's
Yeah,
why.
that's a similar, it's interesting. Yeah, there's a lot of connections between quilting and knitting and crochet. There's a lot of mathematical connections in there that you can play with your students.
Okay.
Right? And
That's
one
my
of the nice
CD on seeing this week. Check. I had a really hard time finding what's my CD on seeing this week. I couldn't see very well.
God will always give you something, right? He'll reveal himself somehow. Okay, any questions from page 4? Right. So, of course, don't forget that we're here for you. I just want to give a shout out to Babs because if you remember last year, we had 2 curriculum assistants that were dedicated to the math map. And we're so excited for the middle of the country that gained Shauna as their as their regional manager or sales manager. We're so excited for her leadership there. But it means that the Babs is carrying that weight herself. She is doing all your equipping calls. She is hosting um, your help desk. She's managing the forums. She's answering your emails. She stays up late. I see her sending messages late at night. So she really is amazing. And I just want to give a shout out to her because she takes it so seriously to support all of the families. And so um, know that she does that with a glad heart and and take advantage of that opportunity that we have to support you. And so that said, we have a couple of questions that people sent in, and somebody sent this question in, and they asked what this part means for the reflection. And so I want to point out here, without looking at all the lesson pages, but really just helping to see that these ideas go together. When we talk about reflection in the coordinate plane, so if I have my plane, right? And I say, well, I'm going to reflect my whatever it is that I'm reflecting. So if it's a point, if it's a figure, right? So maybe I have a triangle. Let me change my color. Right? So if I have a triangle here, and I talk about reflecting that, I need to say, what is it that I'm reflecting across? And so the lines of reflection that we are emphasizing in the math map are going to be a vertical line. Let's, I'm going to use a highlighter here. So my vertical line, x equals c, is a vertical line. So I could reflect that triangle across that vertical line. I could also look at reflecting across a horizontal line. So y equals c is a horizontal line. So I could have my horizontal line be anywhere, even going through that figure, and I'm going to reflect across that horizontal line. When it says to reflect around the origin, what that essentially is going to look like is I've reflected across the X and the Y axis, or rotated 180 degrees. So, right. So there's my origin, and that's what it would look like. So I'm just going to do this sort of like 180 degrees to show you this idea that I've reflected across the X and the Y in order to end up with this 180-degree rotation, which is reflection about the origin. Then one that's very common is the y equals x line. And so that's this line here that actually goes through the origin, although I didn't draw it that way. The reason why reflecting across the y equals x line is used so much is that if I have a function and its inverse, they are going to be reflections of one another across that line y equals x. And so I'm taking this figure and I'm flipping it across that y equals x line. And then the last possibility that we're going to take a look at is y equals negative x, which is this line here, right? And so you can see, depending on which ones of those lines or that point, in the case of the origin, I'm going to end up with a different reflection each time. So above that, I don't have the whole page there, but I'm pretty sure we have above that that we have the point reflections, but then we also have what this particular section is about. You're not going to see, I don't even think it's in binomials. I think least maybe starts doing this in polynomials, is that if we have a relation, let me just change to a pen here. If I have some relation such as y equals 4x plus 1, and if I wanted to reflect that across x equals 4, so let's say my line of reflection was x equals 3, then I'm going to substitute, right, where it says whatever y equals r of x is, what in place of that x, I'm going to put in negative x plus 2c, which in this case is 3. And so here, once I reflect this, I'm going to take my 4 is going to stay the same. My 1 is going to stay the same. But where I see x, I'm going to replace that with negative x plus 6. And if I was to multiply this through, I would see that I have negative 4x plus 24 plus 1, or negative 4x minus 20, plus 25. So now if I was to look at the graph, and I had, here's my 1, and then 1, 1, 2, 3, 4. So roughly speaking, that's 4x plus 1. And if I was to reflect that across x equals 3, so that's 1, 2, 3. So here, let's say this is about x equals 3. If I see here, right, my intercept's going to be way, way up there at 25, and my slope is going to be negative 4. And so it's going to graph, right? This is going to be my reflection. And so that's what this particular section of I2 is showing us, that at any function that I have or any relation that I have, so this would also work for circles and ellipses, that if I want to reflect across one of these lines, I'm going to change it as that rule says on the right-hand side. So, I know that's a question that was sent in, but does anybody who's live with us have any questions about that?
It was actually my question. I think
Oh.
the confusion was like the C and the R, because like is there like some definition of C that we can find and some definition of R? Because whenever I see R, I'm like radius, but I'm like, wait, no, that doesn't make sense.
Sure. So what this is, I'm just going to put it up here. So when I say y equals some, right, we usually say f of x because f stands for a function. And we really wanted to be clear here that we were talking about a relation. We wanted to be clear that in this case, where we could also apply these same reflections to circles and ellipses, that's why we chose to use R. It just stands for relation. That's all that means. And then anytime we see those lowercase letters that are not italicized, those are parameters. And a parameter is just, to most of us, it feels like it's a variable because it's a placeholder for a value. But it's a different kind of value because it's a placeholder for one specific value at a time. So when we think of X and Y can be all of, right there, we're describing all of the values of X and the relationship between that and all of the values of Y. When we see those lowercase a, b, c's in this case, they're constants. And once we pick a number, it's fixed at that number. So it's only representing one number at a time. It's not representing everything. It's saying I'm just representing one number. And once I fix that number, that's it, right? It'll define that one particular line or that one particular circle. it's a different kind of a placeholder. So that's why we call them parameters. So in this case, C just really stands for constant. And so when I say X equals C, I'm just saying it's some number. It's just representing the number. So once I plug in that number, so in this case, X equals 3, my constant is 3. And now I can use that in the place of C on the right-hand side. Does that help clarify that?
Right. So whenever I see X equals 3, I would plug the 3, like in my mind, I'd plug that into the X value of the Y equals 4X plus 1. But instead, like it would be better represented as C equals 3. So you're just like contained
Yeah,
within the.
so here, this is telling me this is my line, X equals some value. And then, oops, I don't know how I'd manage that. Um, sorry, I'm not sure what my screen's doing there. How it's making me have a magnifying glass. All right, let's go back to the pen. Okay. So here, when I see this, it's describing a vertical line because I'm saying that X always equals some value of C. So when I wrote this, I wasn't saying X is globally 3 in this equation. I'm saying that this is the line. That's where we have to remember that this is my line of reflection. And so now I'm actually not defining one value of X, but I'm saying that if I was to graph this, X is 3. So when Y is 0, X is 3. When Y is 1, X is 3. When Y is 2, X is 3. If it's negative pi, X is 3. And so it gives me my vertical line. So that's the part, maybe I should have written that here. If I had written line of reflection, that might have helped us to keep straight that what we were doing was not defining X, the variable was 3, but that we're looking at that whole line that's defined by X equals 3. Does that help clarify that a little bit?
Yes. I wouldn't say it's exactly crystal clear. I'm going to have to work through it some more, but yes, that makes a lot more sense. Thank you so much.
Oh, you're welcome. Any other questions? All right. So looking at book 16, page 12, the question was, is there a reason that part of the graph is a dashed and or is it just showing that it's a repetition? And that is all that we're trying to do here is to show with each of these, right? It's not just in this case, but anywhere that you see in lesson 16 that we have a solid line for a portion of the graph and a dashed line for the rest of the graph is just to try and emphasize the period, right? One period is that solid line, and then the dashed is showing the repetition, right? Because we just want to help kids to see that these are what we call periodic or cyclic functions, meaning that they just repeat over and over and over again infinitely, which is one of the things that makes them so useful because there's a lot of things in our world that are cyclic, right? So what are some things that happen in a cycle or in a pattern?
My mood.
Oh,
Coming to perimenopause, it comes in cycles. My husband can see patterns.
Well, it's true, right? It's true. Can you imagine? Like, imagine if this was, you know, if I turn my pen on again, right? Like, imagine if your mood, uh, I'm just gonna give us a couple of illustrations here, right? So if this was your mood, right? That would be pretty discouraging, wouldn't it? Like, it's never ever going to get better. Right. And we know that life is never really like this. It doesn't just get better and better every day. Right. Life is cyclic. We do have highs and lows. So I think that's a really great example. And and I think that's helpful for our kids, right? Because
Mhm.
we might sit here and go, it's not always going to be hard. And it's not always going to be great. We as adults we see that. Our kids don't always. And especially when things are hard or they're having a really bad day or nobody likes me, we tend to start talking in absolutes, right? And they start to think it can't ever get better. And here's a way we can use math to say, well, no, look, yesterday you were up here, you were having this great day, we had ice cream, everything was good. And now you have to pick up your room and it's down here. But guess what? Tomorrow we're going to the zoo, right? So helping them to see that maybe helps them to and not always think this is the worst thing ever and it's never going to get better.
It
Right? To
reminds me
recognize that.
of the book of Ecclesiastes where King Solomon talking about seasons. And so there are seasons. There's seasons for complex. There's, your sibling is having a season of rest and you're having a season of struggle and it's going to change. And so that's important. Thank you. Thank you for plotting my mood on the National Book Club. I forgot it's a National Book Club. Cut that out, please. Sorry.
Actually, I think you have to probably everybody's going, oh, I can so relate with that. That is such a relatable thing because, all right, I mean, I have children that we struggle with that, right? Like things are so bad. And one of my children tends to feel things more outsized than the other one. And so helping them to see it's not always here, right? And but also spiritually, right? That God is it. Sometimes we all want to stand up here, but when we read the Psalms, right, we see these images that God is with us in those lows. And so just spiritually going, hey, the Bible talks about this. The Bible talks about the fact that sometimes we feel like we're flying on eagle's wings and sometimes we're really stuck. So pulling it back to the Bible, just like you did with Ecclesiastes and those seasons, right? Looking at the Psalms and different things, like this is how God designed it because he knows that we would be discouraged if we were always in the valley, but he promises that he'll be in that valley with us. Some other things you talked about there, the seasons, right? So if we were to talk about the distance we are from the sun, sometimes the distance is slow, sometimes it's far. It might not be a perfect sine curve, but we see that our distance from the sun changes, right? The length of our days, it gets longer, it gets shorter. If you live on the coast and you see the tides go in and out. Um, Even our electricity, right? Our electricity goes in waves, our light goes in waves. So all of those things that are going in waves, we can use our trig functions to help us to model that. Of course, right now, I made my son laugh because we've been watching this storm that is barreling, soon to be barreling across the country, right? It's still actually off the coast of California, but we keep talking about models and models and models. Well, the models are all math. They're all mathematical models that are forecasting what's going to happen this weekend. And on Sunday night, right, one of the models had us getting like 2 feet of snow. And then on Monday, that same model said, oh no, you're going to get about 1.5 feet of snow. And then yesterday, that model said we were going to have 3 feet of snow. And now that model's down to 6 inches of snow, right? And so it's a great opportunity to talk about, hey, this forecasting and all these models, it's all math and it's all putting in data. And they're using all of these different functions to try and figure out what's most likely to happen, right? And yet, I made my son laugh because I said, yeah, you can't trust the math. And he's like, Mom, I can't believe you said that, right? You of all people. But it's a good reminder that when we start to look at mathematical models, that they only take a portion of reality, right? And so when we think about all these different weather models that they're using, that they're all trying to pick which variables they think are going to be the best. And then they all have their equations that they think relate those variables the best. And over time, as our computing power has gotten better, we can look at more and more variables. But we all know that we're sitting here, we're humans, that you just look out your window and you can see that there's so much going on, right, in our physical world that a computer can't possibly measure every single little thing, right? And so it's a great opportunity to say, yeah, these are great functions for modeling those things, but they're they're not mirroring all of reality. That's why they can sometimes be wrong. So lots of things we can talk about when we think about these trig functions and the fact that they are repeating themselves. And then, so this question we included because we've sent it to Lee and our editing team to take a look at this. But I thought it was a really great question to talk about as a parent, right? Again, that freedom that you have as a parent to make this be what you want to be, um, but also to have a conversation with your student when they feel like there's a contradiction. So if we look here, we see that it says to round the sides to the nearest whole number. But when we look down here, we see that it's rounded to the nearest tenth and right, these are all rounded. And then this one is out to the hundredths, right? So it feels like it's maybe not as consistent as we think that the solutions might feel. So I thought it'd be a great time to talk about as parents, right? What would you tell your students when they see something like this?
I think for my kids, I usually just work through it with them, ask them to show me. And if I can see where what we've done is different, and if I'm comfortable with that difference, like, okay, we're moving on. I see where you got what you got. I'm comfortable with the difference, and we're good. But I do tend to kind of be the I'm allow it kind of parent.
I think it's great, right? To work with them and say, cool, let's take a look at this. So at the end of the day, right? At the end of the day, is it changing the work we're doing to change where and how we round? Right? Looking at the concept, are we still doing the same concepts, whether we say 4.6 or 5?
Yeah.
Whether or not we round might change the calculation, but it's not changing the concepts that we're practicing. Right? And so I think that's the first thing as a parent to go, oh, wait a minute, look, what are we practicing here? Am I trying to practice the calculation or am I trying to go, what's the pattern here? Right? What is the apothegm? Let's talk about what's the apothegm. Let's stop. Okay. And this is how we're doing this. And okay, we found our apothegm. What is the side link? Can you point to the side link? Yep, we can. Okay. So as we talk through these things with our students, um, and and again, feel that freedom to recognize, oh, there's a disconnect. So you know what? We're going to ignore that part that says round to the nearest whole number, and I'm going to tell you, I want you to round to the nearest tenth, or I want you to round to the nearest hundredth. Or encourage your student to say, well, do it both ways. Do it rounding to the whole, rounding to the nearest tenth, and rounding to the nearest hundredth. Okay, now I want you to look at this and say, okay, well, if we had measured this and gotten a whole number, what would the significant figures, right? You can take this and say there's these apparent disconnects. Well, I want you to explore that and think about all of the possible um, ways that this could impact this problem. So I can take that student who is confident and really push them to think about doing this 3 different ways and comparing the 3 different answers and discussing significant figures. Or I could say, okay, yeah, you don't need to worry too much about all of the calculations that you're doing here. So you can go ahead and round all of these to the nearest whole so that you're not having to worry about decimals. Or hey, we're using a calculator. So what matters to me is that you're rounding. So use your calculator and and round to the nearest whole, then round to this, but you can still use your calculator. So I think that there's a lot of ways when our gut says, oh, wait, this doesn't match what I expected, um, is to divorce ourselves from where we've been with other math curricula and thinking that we have to match the solutions entirely and come back and go, okay, well, really, where, right? This isn't a right or wrong. It's not a national test where, gosh, we've got to make sure we get this exactly right. Let's think about this. There's a disconnect here, but we can work this out together, right? What should that have been if it had rounded to the nearest whole number, right? What would that have looked like? And even just doing that, right, to say take these answers that are here, but round them is a practice in rounding. So, anybody have anything they'd like to chime in and share about that? No. All right. Well, that brings us to the last of our questions that were sent in. Did anybody bring questions today?
I had a question, but it's in the rationals. I don't know if you were going over rationals since it's not technically out yet.
No, we can do that.
Okay.
As you ask it, Babs is going to create another slide and put it up there. So let her know first where it is, and then we'll talk about it.
Okay, it's in book 17, page 8. And I looked in I have 4 different levels at my house, and so I could not, for the life of me, figure out what we were doing. It's the top section of that page for the simultaneous in slash equalities. And it's having you do greater than or less than, and I don't know what we're looking at. So I tried to look at the previous ones, but all of the other ones, and even the after, I was like, let me look at complex and see like if I can if it looks, I don't know if it looks any different, but even that didn't have graphing the like greater than or less than. And so anyways, that's what I tried several times, and I just told my daughter I have no idea. So I'll ask.
Well, good. Well, I'm glad you did come and ask.
Okay, I pasted it in there, so I guess we're just waiting for it to upload. It's in there. It's kind of similar to well, not really. Okay, it's kind of similar to book 1612, but it's not.
Oh, not like that. Okay.
No. I don't know what to do to make it like go faster. Like I
It keep
saved it.
I keep seeing it pop up, but yeah, I think it is the other. I would say this: the other books that we have. So I've got integers, I have digits, and I have decimals. And the other ones, the only thing that they do with these inequalities is have you say if it's consistent or inconsistent, and then if like how many intersections it has. So this is like the only one that I see where you're having to like look at those and then see what's greater than
Okay.
less than.
Right. It's there. Yay.
Yay.
All right. So let's take a look at this first one here. And we're given these hints as on the left of each of these, right? So here's the hint as to which of our functions we're looking at. So 2 over x is this part right here, right? So even the first step I would say with your student is to say, okay, I want you to go ahead and maybe highlight. So let me turn my highlighter on. Let me erase this and do it. Oh no, come back. Okay, highlighter. So I would say, let's take this, right? So 2 over x looks like this, and I'm going to trace that function. And then maybe with a different highlighter color, I'm going to say, okay, this is y and 2x, and it looks like a line. And so just doing that might help your students to start to see what those 2 different functions are that they're looking at. And then once I've done that, now I'm going to take a look and I'm going to say, okay, look, this blue area right here, notice in relation to my orange, is it above or below?
It's below the bottom one.
It's below. And
Sorry.
even with my upper one, it's harder to see, but it's still below it, right?
Okay.
If I was to take a um let me see if I can, yeah, I'm going to do it this way, right? If I was to take a vertical line, right, and I picked out any vertical line, my orange is always going to be above my blue, right? So the blue is my Y, right? So that the blue or the purple is going to be my Y, right? This is my Y. If it's below, do you think that's less than or greater than?
Less than.
Less than. Yep. So now let's look with respect to the green with the line. When I look at the line, the green, is that blue above the green or is it below the green?
So that one would be above,
Above. So it would be greater than or less than?
greater than. And then
Greater than.
so it would be greater than or equal to because it's solid and not dashed.
Correct.
Okay.
Yep.
Okay.
So here, this time, my X, let me change my color, right? So my X is this picture here. You could tell me, right? I'm gonna highlight that. And now I'm gonna look here and I'm gonna say this one's a little bit different, right? Because this time I'm looking at the whole shape, which is gonna be my circle. That's a little bit different, and this is still the shape that I have. And so now I want with my top one, again, I'm looking at right this area here. With respect to the orange, is it above or below?
Below.
Below. So it's going to be less than, and it's a solid line, so it's less than or equal to. The
Okay.
one below that, now it's a little bit different because it's that closed shape. So we're going to see that here and here where we have these closed shapes. If it's a closed shape like that, I want to talk about, is it inside or is it outside?
Okay. It's inside.
It's inside, so it's going to be less than because it's inside.
Okay.
If it was greater than, it would be outside. So that's what we see here is it's outside that circle. So it's going to be greater than.
Okay.
So I think maybe if you highlight with with your student and
Yeah.
say, okay, that might help them to see um, how those relationships fall.
Okay. 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 That makes a lot more sense.
Good.
I knew it had to have something to do with the blue, but I didn't know exactly what.
Yep. That's it.
Well, and
You
Awesome.
got
Thank
it.
you.
I'm glad you walked through this because when you first started, I was like, wait a minute, how does she know that the curved lines are 2 over X? And it's literally right beside it, but I didn't even see, I wasn't even taking time to like find that. I was just like, did she just know that those curved lines were 2 over X? There, and I think I finally got it once you highlighted it on the second column that the orange, the line. I was like, oh, that's where she's getting it from. So yeah, that makes sense. All
Well,
right.
good. Do you have any other questions? All right. Well, thank you so much for coming. Thanks for bringing your question. I'm glad we were able to answer that and step through that. And I'm sure that will help other people as well. And so just everybody stay safe with the coming weather. It looks like it's going to impact a whole bunch of people in the US. I know we're looking at ice, but it looks like dangerous cold and lots of precipitation across 2/3 of the country almost. So please be safe this weekend, and we'll look forward to hopefully seeing you next week. If we don't have power, then I guess we won't. But hopefully we'll all be up and running. So have a great week.